Hello, ladies and gentlemen. Welcome to Parallel and Perpendicular Practice. So we're going to jump right in with a quick little thought experiment to help us remember about how we measure steepness. So you're hiking up a mountain, you've broken it up into 4 stages, and I just want to know which stage, 1, 2, 3, or 4, do you think would be the steepest part of your hike? So go ahead and pause now and try to work that out. All right, so I'm going to have to go with either stage 1 or 2. It's kind of close to tell. It's a little tricky, but the key here is comparing the amount of rise to run. Whenever you're measuring steepness, what you're doing is you're calculating the slope. How much does it go up divided by how much it goes over? And since we don't have an exact coordinate grid to use numbers for here, we're just kind of comparing those sizes. And it looks like these ratios are about the same. 2 goes up a little bit more than 1, but it also goes over a little bit more than 1. 3 definitely goes up the most, but it definitely goes over the most. And I think when we compare those are closer to the same, whereas here it goes up more than over. 4, while you're the highest point on the mountain, you hardly have any vertical climb left. It's pretty much leveling off. It's almost all horizontal movement at this point. So that's the least steep. The next least steep, and then we're pretty close between 1 and 2 for which is the steepest. But I just put this on here to help you remember how we measure, what we mean when we talk about the steepness or the slope of a line. So let's jump right in. This is a pretty long one with a lot of arithmetic, like probably more than we've done all year, like combined. So jumping right in, there is this thing called slope-intercept equation, which is y equals mx plus b, where m is your slope or how you move on a graph, and b is your beginning point or the y-intercept on the graph. So like down here, this would be my beginning point, and then to get there, I'd have to go down some and over some. That would be my slope, the rise and run to move over. Y-intercept is your b. How you move from point to point is your slope. So what we've been given here, this is how we want our equation to look at the end. Y equals some number x plus or minus some number. Right, that's the slope-intercept equation. But we're not given the slope and y-intercept. What we're given is the slope and a random point. So there's this other equation called point slope form where you go y minus y1 equals mx minus x1. The x and the x1 and y1 are just the x and the y from your point. So this is x1, this is y1. Try to remember, they're not x and y because they're one point that is on the line. The x and y that are in the equation will be the x and y that are in our equation as an answer. The y1 and x1 are what you're going to replace along with your slope, the m. So let's plug all that information in and go y minus 3 equals negative 4 x minus 0. You're going to solve to make this equation look like that by doing 2 things. One is to distribute. So you'll have y minus 3 equals negative 4 times x, and negative times negative is a positive. 4 times 0 is 0. You don't really need to write that, but yeah, it's there. And then you finish by adding the 3 across. Because the whole idea is in our final equation, y is by itself, so I want to get y by itself down here. I have to get rid of the parentheses so that I can add the 3 with something that's not in parentheses. So I've got y equals negative 4x plus 3. If you feel okay with that, go ahead and pause and try this next one that has a little bit of negative work and a little fraction work. If you're not really comfortable yet, feel free just to keep watching, and I'm going to keep rolling right on through because this is kind of a long one here. So I'm going to work with this one by doing y minus y1, which is negative 8, equals m, which is 1/3. And I'm still using the same equation right here. We'll use this every single time that we have a point and a slope, which is like all of them. So y minus y1 right there equals m times x minus x1. Now, 2 things here. One is when you have minusing a negative is like taking away debt. Subtracting a debt is like giving someone money, right? If you owed me $8, I'm like, don't worry about it. It's kind of like somebody gave you $8 to pay off your debt. So it's a good way to remember that when you see minus a negative, you can switch those to plussing a positive. Subtracting a negative is adding. If you want more clarification on that, feel free to email me about it or get a hold of me somehow, and we can chat. But for now, just know that minusing and negative, you can flip them both. If there's only a single minus sign, though, you want to keep it because here it's just subtracting. But when you have minus followed by a negative, you can switch them. So that becomes y plus 8. And over here, when you distribute a fraction, please, please, please remember that fractions are just division, right? When I multiply 1/3 x, there's nothing to really multiply. I just write 1/3 x. But when I do 1/3 times 3, that's the same as doing 1 times 3 divided by 3. You just divide by the denominator. That's all there is to it. 3 divided by 3 is 1. So that's it. 1/3 of 3 is 1. Subtract your 8 across to get y by itself. Y equals 1/3 x minus 1 minus 8 is -7. All right. So when you're given a point and a slope, you're going to use that point slope form to plug in your x1, y1, and m and solve for y. Get y by itself so that you get your slope-intercept equation. We use slope-intercept equation because it's the easiest to graph. It's got your beginning, point, and slope, and it's kind of the most condensed, right? This is way more simplified than this original nonsense that we started with over here. So we want to get it simplified so that it's easier to work with. Okay, well now if you're given just 2 points, you actually have to find the slope. So there's a complicated equation that goes like y2 minus y1 over x2 minus. Don't think about it that way. I mean, you can if you know the equation, but the way I suggest thinking is just simply rise over run. Rise has to deal with the y-axis. So think about how much the y variable changes, the y value. -2 to 4. If it's -2 degrees outside, and then it goes to be 4 degrees outside, it went up 6 degrees. That's your rise, right? Your y's, the rise is y changed by 6. And then think the same thing here. How do you get from 3 to 5? You add 2. That's your run. Your x is your run. It increased by 2. That's it. That's how you find slope. It does the same thing if I did 4 minus -2. Minus the negative is positive, and I get 6. 5 minus 3 is 2. Oh, hey, look, I got the same thing. Oh, how about just think about it, right? Spend some time thinking instead of depending on formulas. Now, as I say that, we're going to use this formula again. Before you do that, if you can, simplify your slope. 6 divided by 2 is 3. So I've got my slope like I had before, and I need to pick one of these 2 points. Super doesn't matter which one you want. Eeny, meeny, miny. Let's do the one without negatives. All right. Y minus 4 equals slope times x minus 5. Distribute. And add the 4 across. Bada bing, bada boom, that's it. All right, so here's one I will have you pause. Try to pull together what I've gone through so far and see if you can do number 6 on your own. All right, I'm actually going to cut back in before I finish the problem because I have a feeling that some people are either going to make a mistake here or they're going to get to here and just have a heart attack and freak out. So real quick, if you want, you could switch this to 0.25. You can switch your fractions into decimals. It's not mathematically wrong. It's a little taboo because we like seeing the rise and run. So like, especially with slopes, it's kind of nice if you leave it as a fraction, but it's not the end of the world if you don't. And so what we have here, sorry, just making sure I didn't make any mistakes. I felt like something went weird. Nope, we're good. So we have this fraction 1/4. First off, please know that 1 divided by 4 is not 4, and it is not 1. It is 1/4, or 0.25. This is different than if you have 4 divided by 1, right? See if it's upside down. This is having 4 loaves of bread all to yourself. This is having 1 loaf of bread split between 4 people. That is a different scenario. It's got a different value. So we leave this as 1/4 and go ahead and distribute that in. At least that's what I'm going to do. If you wanted to, you could switch it to a decimal, but it's definitely not 1 and it's definitely not 4. And when I do that, I'm going to get 1 times -6, and -6 divided by 4 is a spot that's not going to divide out evenly. So this is where I kind of want to think -6 divided by 4. Well, 4 goes into 6 once with 2 left over. So if I'm doing a decimal, that would be 0.5, or I could write -1.5, or I could leave it as -3/2. There's lots of different options for the way you want to write this. If I'm using my personal preference, I always leave a slope as a fraction, and I use my y-intercept as a decimal, just my personal preference. So I'm going to take -6 divided by 4, right? Because 1/4 of -6 is -6 divided by 4. And I'm going to use -1.5. For me, that just makes it easier to visualize where it is on a graph. And if I add 4 over now, it's easier to work with decimals than it is to work with adding fractions. So just my personal preference, you do you, girl. 1/4 x gives you -1.5 plus 4. Yeah, sorry. I thought I was going to get a different answer than what I worked out before. Negative, positive 2.5. Yep. Yep. So if you owed somebody $1.50 and you got $4, once you spend $1.50, you would have $2.50 left over. -1.5 plus 4 would leave you with $2.50. That was kind of a mean one to turn you loose on. Sorry about that. But yeah, this is the general idea. You find the slope, you pick one of the points, plug in your x, y values, distribute, add the number over. Sometimes you'll get these fractions and decimals. A lot of times they work out cleanly, though. So just be mindful of that as you're working through. Now, as we go to write the equations of the lines from the graph, you're going to use this format again of y equals mx plus b, where we're trying to fill in the slope and the y-intercept for both of the lines. Fill in the blank, right? So let's look at this line on the left here first. Well, to find slope, you just count how far up and over. Remember, rise over run. 1, 2, 3, 4, 5, 6. Yep, up 6 and over 1, 2, 3. So 6 over 3 is a slope of 2. So I've got a slope of 2. 6 divided by 3 is 2. And my y-intercept, I've got two options here. I could pick one of these points, use the slope in that point, and do all this up here. Or I could try to use my reduced slope to see if I run into the y-axis. So from here, I can go up 2 over 1. Look, I'm back on the line. Up 2 over 1. Hey, look, that's on the y-axis. That's what I'm looking for. Your y-intercept is where your line hits the y-axis. It hits right at 4. No work required. If I had picked the point and the slope and done all the calculations, I would get the same equation every time. Here I've got a slope of 1, 2, 3, 4 and over 1, 2. So I'm going up 4 over 2, which also reduces down to a 2. Is that a coincidence or is that okay. And my y-intercept is actually shown to me. I have a -3. So instead of a plus, I guess you could do plus a negative, but that's the same thing as subtracting 3. I like using a minus sign to show my negatives. All right, so we got 2x minus 3 and 2x plus 4. Go ahead and see if you can do number 8 over here. I promise this one's, there's no curveballs here. You're not going to beat your head against a wall for this one. So go ahead and pause and try this problem on your own now. All right, so there was a little fraction left over. Hopefully that didn't cause you too much confusion. You had to go down 6 and over 4, which that fraction can both be divided by 2, so it reduces down to down 3 and over 2. Now, please remember the idea of uphill, downhill. These lines are going uphill. If you were walking left to right and you got to that line, you would start heading up. Up is positive, just like on the y-axis. Down is negative. So when you see downhill sloping lines, you better have negative slopes or else you've done messed up already. So that -6 force reduces to a -3/2, and the other one you just go down 3 and over 2. So that's got the -3/2, and both the y-intercepts are marked. That hits at 7, that hits at 1. There's your equations. Now, I hope you can notice right away, we've got parallel lines in both these, or what look to be parallel lines, and they both have identical slopes. Different y-intercepts, but identical slopes. That's going to happen every time with your parallel lines. Same slope, different y-intercept. Now down here, these look to be about perpendicular. So let's look at what happens with these guys. Here we go down 1, 2, 3, 4 and over 1. So that has a slope of -4 over 1. Now this divides, right? 4 divides by 1 to be just -4. This one, the other line, goes up 1 and over 1, 2, 3, 4. So this has a slope of 1/4. This does not divide, right? This is 1 loaf of bread over 4 people. You do not get 4 loaves of bread each, right? That does not divide. 4 divided by 1 is not 1 divided by 4. This one stays 1/4. Again, both your y-intercepts are marked. So the top, the downhill line has y equals negative 4x plus 1, because that's where its y-intercept is at. And the other line, the flatter line, has a slope of 1/4 and a y-intercept of negative 2. So y equals 1/4 x minus 2. So you can see there's some similarity between our slopes, but they're definitely not the same here. They're not even just like opposites, or I don't know yet. Let's look at the other one. See if you can work out this other one. I'll warn you, it's a little tricky. So if you don't want to pause, that's fine too. But I'm going to go ahead and blast through this one real fast. So we've got a slope of 1, 2, up 2 over 1, 2, 3. So we've got 2/3 for our slope and a y-intercept of negative 2. That one's not too bad. This other one's a bit of a pain. You go down 1, 2, 3, and over 2. So negative 3 over 2. And here it crosses right between 4 and 5. So we've got a y-intercept of 4.5. Now, if we're being honest, like if this was the SAT, I would not recommend just looking and guessing like that. So here's what you could do if you weren't certain. Here, let me pause real quick and work it out. All right, so you could take, once you looked and found your slope was down 3 over 2, you could take that slope and one of these 2 points here, I took this one here, the point 1, 3, and I used my point slope form, y minus y1 equals mx minus x1. Distributed this in to get negative 2/3, or I'm sorry, negative 3/2 x. And when I did negative times negative, you get a positive. 3 times 1 is 3, divided by 2 is 1.5. So then when I add the 3 over, you do confirm that it is exactly halfway between 4 and 5, so you have a y-intercept of 4.5. That's a way to double check if you really want to be certain, but in our case, this is a pretty long practice page, so I'm trying to go through it quickly as possible for you. So let's look at the comparison here, right? On the parallel lines, it was easy to see they have the same slope. What we have here is called the opposite reciprocal. So opposite just means changing the sign. If one of the lines has a negative, the other has a positive slope. If one has a positive, the other has a negative. That's the idea of opposite. Reciprocal means that you're flipping the fraction over. 2/3 is the upside down of 3/2. 3/2 is the upside down of 2/3. And actually here, 4 or negative 4 is the ups. It can be written as 4 over 1, right? 4 divided by 1 is 4. If I flip that and change the sign, that's where you get the 1/4 from. It's the opposite reciprocal of negative 4. Change the sign and flip the fraction. If it's a whole number, put it over 1 and then flip it. So perpendicular lines will have an opposite reciprocal. Parallel lines will have an equivalent slope. Now, let's see if we can put that to use back here. So determine whether the lines described by these 2 equations are parallel, perpendicular, the same, or they intersect but aren't perpendicular. So again, if they're parallel, they'll have the exact same slope, but different y-intercepts, like what we saw in the front. Perpendicular will have opposite reciprocal slopes. The same line has the same slope and the same y-intercept. We would get that as we work this out, if you end up with the exact same numbers, that's just the same line, right? If they both turn out to be the exact same equation, you couldn't tell right away sometimes because they're in different formats. Both to be y equals some stuff. If they both equal the same stuff, they're the same line. And if there's any other scenario where they just have like randomly different slopes, like let's say we had like 3/2 x plus 1 and like 4x minus 3, this would just be 2 intersecting lines that aren't perpendicular, because these are not opposite reciprocals. They're definitely not the same. So they would just be 2 rando lines like you've seen pretty much all through your mathematical career so far. Just 2 random lines. We're looking at special cases, or we're looking for special cases. So what you want to do is get y by itself in both of these equations. Y plus 5 equals 2/3 x plus 3, and 2y plus 3x equals 2. So to do this one is just like point slope. You distribute, you get y plus 5 equals 2/3 x. 3 times 2 is 6, divided by 3 is 2 again. So I just get a 2 right here. Subtract the 5. So my final equation is y equals 2/3 x minus 3. 2 minus 5 is -3. So that's the slope-intercept form of this first equation. Now the other equation, I need to move stuff around to get y by itself. So I'm going to move the x over to the other side. Now I cannot combine these together because this has an x and that doesn't, and that's okay because I don't want these two together, right? I'm just going to write it as -3x plus 2. And then to get y by itself, 2y is 2 times y, so if I divide, I'll get y equals -3/2 x, and 2 divided by 2 is 1 for that other equation. Now let's compare slopes. They're definitely not the same, but check it out. They are opposite reciprocals. 2/3, 3/2, positive, negative, bang, they're perpendicular. We know that because they had opposite reciprocal slopes. All right, similar here, find the slope-intercept equation of the line that passes through this point and is parallel to this line. Well, to find out what the slope of this line is, I need to solve for y again. So I'm going to bring the x to the other side. It's subtracted or like a negative there, so I'm going to add it across. 3y equals 9 plus 6x. Divide everything by 3. Y equals, and I'm going to flip this order so that I have my slope first, just because I'm OCD like that. So my slope of this line is 2. So I need it to be parallel, meaning it has the same slope. So the slope has to be 2, and it has to go through this point. We're basically back to the very first kind of problems we were looking at. We've got a slope. We've got a rando point. We need to find the equation of the line that goes through that point with that slope. So y minus -2 equals 2 times x minus -5. Minus a negative. Distribute your 2. Y plus 2 equals 2x plus 10. Subtract the 2 to get y by itself. The equation of the line that's parallel to this guy with its 2 slope would be 2x plus 8. There we go. All right. Couple more, guys. Hang in there. I know this is a lot, and I'm just barrage of information right now. Try to keep up and pause whenever you need. Rewind, go back, play it at half speed, whatever. I'm just trying to keep this bad boy under a half hour. So once again, I need to find out what this slope is, and I need to get y by itself to do that. So be careful. You could move 2y over, but then you'd have to move 10 this way. So what I would suggest doing is subtract 1x on both sides. I always move the x when x and y are on the same side. It gets you to the answer in fewer steps. You just have to remember that minus sign, if there is one, sticks with the 2. It's like a negative on that 2, so that when I divide, I'm dividing everything by a negative. So y equals negative and negative is positive 1/2 x. Positive and negative be a negative. 10 divided by 2 is 5. So here's the equation of that line in slope-intercept form. It has a slope of 1/2, and I want something that goes through this point and is perpendicular to the first given line. So I've got a -2/1 or -2 slope going through the point 2, -4. Point slope form, y minus a -4 equals -2. So I need a negative opposite, x minus my x value. Distribute that -2. Y plus 4 equals -2x plus 4. Subtract the 4. And oh, that's interesting. 4 minus 4 is 0. So I just have y equals -2x. You could put plus 0 if your little heart wants to. It doesn't matter either way. 4 minus 4 is 0. Adding 0 doesn't do anything, so I tend to drop it. But if you want to keep your format the same so that you have some x plus a number every time, go for it. Okay. Last one, and it's a doozy. So it's going to be perpendicular. It needs to be perpendicular to the line that passes through these 2 points. So I need to find the slope that goes through those 2 points, take the opposite reciprocal of it, and then use that slope at that point to find the final equation. You ready? So the slope here, rise goes up 6, and over from -1 to -3 is actually getting smaller. If I owed someone $1 and then I owe them $3, I actually went 2 more into debt. So this decreased. So my run is a negative. Positive divided by a negative is a -3. If I'm perpendicular to a line that has a -3 slope, that means I need to have a slope of positive 1/3 because that's the opposite reciprocal of -3. It goes through the point 6,4. So I have y minus 4 equals 1/3 x minus 6. Distribute y minus 4 equals 1/3 x. 1 times -6 is -6 divided by 3 is -2. Add the 4. Y equals 1/3 x plus 2. Bang, bang. Wasn't that bad. Find your slope, take the opposite reciprocal, and find the new equation. Last problem, guys. Here we go. We got 4 minutes and about 10 seconds. Okay, so we've got to do sketch AB on the graph with A is at -3, 3, and B is at 3, 1. So this is point A, this is point B. We get a nice straight line. That's line segment AB. Wanted me to sketch. Determine the slope-intercept equation for the perpendicular bisector. All right, so perpendicular automatically tells me I need to calculate the slope and take the opposite reciprocal of it. Bisector is a word we haven't seen in a while. That's the line that cuts this line exactly in half. And if you remember how we do that, you need to find the rise and run. So it's going down 2 and over 1, 2, 3, 4, 5, 6. And we got to cut both of those in half. So we go down 1 and over 1, 2, 3. Hey, look at that. It hits right on the line. Crazy. And that point cuts AB in half. Now, I just need to take my slope that is down 2 over 6, that reduces to a -1/3, and take the opposite reciprocal of that. So the opposite would be a positive. Reciprocal would be 3 over 1, or just 3. And it has to go through this point, which is 0, 2. Left and right, 0, up 2. So what's the equation of a line that has a slope 3 and goes through that point? Well, y minus 2 equals 3 x minus 0. I always like those zeros. They make the math easy. 3 times 0 is 0, so whatever, I'll put it in. You didn't have to write it if you don't want to. Add the 2 across, though. It's a good placeholder. And ladies and gentlemen, we done did it. This would be the equation of the perpendicular bisector. From this point, it goes up 1, 2, 3 over 1, or you could go down 1, 2, 3 and left 1, and that should form a perpendicular line, which it looks like it pretty well does. And it bisects both at the same time. Woo, 2 minutes to spare. Well, I'm done. You've got 3 sections to work on. I know this section is a pain. It is probably one of the most tedious sections we do all year. So take your time, spend lots and lots. We're going to give you tons of time to work on this. As long as you're using your time wisely, you should be fine to get through this before the quiz and test date. So work hard, ask lots and lots of questions, and as always, let your teacher know what you need help with.